Hi guys, welcome to the Art of Server, and by the time you're watching this video it will be 2021, so happy new year to all of you. I hope that you had a wonderful New Year's holiday, and let's hope for a better 2021 compared to this past year. Alright, so in today's video I'm going to show you something that a lot of people have said is impossible, and that is booting off of an NVMe drive. And so for example, I have here a M.2 PCIe adapter for NVMe drives, and these things are very affordable these days, and M.2 form factors are very popular now, and so you can get very high performing tiny little SSDs, and people tend to like to use these things. But on legacy systems, as an example, this R510, even though this does support UEFI booting, it does not support booting off of an NVMe drive. And so I've had people ask me, hey, I've got my R710 or I've got an R510 or any other kind of older generation machine, and they bought an adapter like this perhaps, or some other type of NVMe drive, and they wanted to boot off of that and install their operating system, and ultimately they find out that they go into the BIOS of the system and it says, well, that device doesn't show up, so they can't choose that as a boot device. And that is true. There's nothing that you can technically do about that other than maybe modifying the BIOS, but that's, I think, usually beyond the means of most people. And so I'm going to show you how to install CentOS 7 Linux on an NVMe drive and still be able to boot your OS on a legacy system like this R510. Alright, so let's go ahead and take a look inside and I'll show you what I got in here. Alright, so here is the inside of that R510, and you'll notice that I have this Intel P3605. This is a 1.6 terabyte NVMe drive, and I have this plugged into the PCI slot number 2 here. So I'm going to install CentOS 7 on this NVMe drive, and I'm going to be able to boot into that operating system on this legacy system that does not support booting off of NVMe. So part of the secret sauce to accomplishing that is two factors. One, the operating system that I'm using, which is Linux basically, has a bootstrap mechanism, and that allows us some flexibility in how we boot the system. And so I'm going to take advantage of that, along with, over here, you will see a USB drive. And on the backplane of the R510, there are two USB slots here on the backplane that you can use for booting off of a USB drive, and I'm going to use that in combination with this NVMe drive and the fact that the Linux operating system has a bootstrap mechanism that allows me to split the booting process between the USB drive and this NVMe, and allowing me to basically boot into CentOS 7 on the NVMe drive and having all the advantages and speed and performance of the NVMe drive. Alright, so let's go ahead and turn this guy on and get on the virtual console. Alright guys, I've got the iDRAC Java KVM fired up here, so let's go ahead and power on this machine. Alright, so the first thing I'm going to do is press F2 to get into the system setup, and I want to show you that the NVMe drive does not show up as a boot option. Alright, so if we go down to boot settings here, you will see under, well, initially we'll see boot sequence. It shows hard drives, embedded NIC, and then the virtual media stuff. And then if you go down the hard drive sequence, you'll see the internal USB, and that's that black USB drive that I showed you earlier on the backplane. And there's also a front USB, and that's because I have a separate USB drive plugged into the front that has the CentOS 7 installation media. Alright, so those are the only boot options. As you can see, there is no NVMe drive or anything like that. But fortunately, as you can see, we have the internal USB drive to boot off of, and we're going to take advantage of that in order to bootstrap the system into the NVMe CentOS 7 installation. Alright, so let's go ahead and get out of this. And I'll press F11 here. And we're going to boot off the front USB drive, which is the installation media. Alright, I'm going to go ahead and just select install CentOS 7. Alright, so we're going to go ahead and select the default English and press on continue. Okay, so here the important part is the installation destination. So we're going to click on that. And you can see that we have the NVMe drive, the Intel P3605, as well as the 30 gigabyte USB drive to select from. Now, one thing I do want to show you, sometimes I've noticed that the installation program, this Anaconda thing, does not detect the Intel NVMe drive. And in those situations, this is what I have to do. So I'll just kind of show you. Obviously it's here, so we're okay, but go ahead and press on, what was it, Control Alt F2, I think gets you a shell. Okay, and from here you can identify the NVMe drive. And what I'll do is use parted, and oops, didn't spell that right, NVMe 0 and 1. And right now you'll see that it has a GPT partition, but or a partition table. If that doesn't exist, and I can redo it right now, go ahead and just create a GPT label on this disk. So I'll do mk label GPT, hit enter, and say, yeah, let's go ahead and overwrite that. And then it'll quit. And so once it has a GPT label on it, I think LSBLK should pick it up. Yeah, so you'll see LSBLK, or the basically list block devices, will show this as a possible block device. And then we can go back to, I think, Alt F6. Yep, and at this point you can then click on refresh, and that drive should then show up properly. Okay, so just in case you don't find your NVMe drive during the installation, that's what you can do. Obviously in this case it seems to show up fine. I've had situations where it didn't show up, and that's what I had to do. So let's go ahead and select both the USB drive and the NVMe drive, and we're going to do a custom partition setup, because we want to make sure that we split the operating system in just the right way so that we can boot off of the USB drive initially and then run the rest of the operating system on the NVMe drive. All right, so I'm going to go ahead and click done to move on to the next step. All right, so first thing we want to do is add the boot partition, so the /boot, and this is going to be that 32 gigabyte drive. So I think I can just go type in 32 gigabytes. All right, and let's modify the devices we're going to put this on, and make sure that it is on the SDC, which is the USB drive, and not the Intel NVMe drive. Select. And so it should only show SDC here, which is the USB drive, and that's it. This is the most important part that in the setup process, is to make sure that this initial boot partition, which is what the system BIOS boot is going to look at, is on the USB drive, because it can see that USB drive. Now for the rest of the operating system, we're going to put it on the NVMe drive. And so we're going to do that by first adding, let's just say, the root. And I'll leave that blank, and we'll just do add mount for now. We have to make some changes here. So for one, we have to make sure this is the NVMe drive. That's the only thing selected, so we don't have a modify option. But in case it does show you anything else, just go ahead and click on modify and make sure that that's on the modified, or that's only on the NVMe drive. Okay, so we're going to change this size. By the way, I don't need the entire capacity of the NVMe drive for or the root, and I'm going to go ahead and modify. I like to name this CentOS _ system, and make sure that you have just the Intel NVMe drive selected here, and we have automatic. That should be fine. Let's see here. Okay, well, you know what, let me modify this again, because it's saying 0 free. I want to make sure that we have the full capacity of the NVMe drive for this volume group. So let's go ahead and see if we can do that. Okay, so now we have the full capacity of the NVMe drive in this volume group, and now we can add other logical points or mount points. So we'll do, let's say well, I want to do /home last. Let's do swap. So for swap, let's do 4 gigabytes. All right, so now I have swap also within that same volume group. So it's taking a little bit of the space from that NVMe drive for the swap partition. And let's put the rest under home. And so according to that, we have 1386.41 gigabytes left. So let's see if we can just use up the rest of that space. Okay, so I have /boot on the USB drive, as you can see, SDC. I have the root as a 100 gigabyte partition, or it's a logical volume really, under the NVMe drive. I've reserved 4 gigabytes for swap, also under the NVMe drive, and I've put the rest of it under /home for basically user space. Now, this is just an example setup. You might not want to partition your system this way. The most important part is to make sure that the /boot is on the USB drive while everything else is on the NVMe drive. All right, so if you were running, for example, a server running applications, you might not care about putting a lot of space under /home. Conversely, if you're running a desktop type of environment, where most of the data is going to be under a user home directory, then this might be the setup for that. But anyway, you feel free to adjust this as is appropriate for your application. The important part again is just to keep the /boot on USB drive and everything else on the NVMe drive. All right, so we're done here. Let's go ahead and click done. And we'll accept the changes. And now we're back here at the installation screen. So we'll go ahead with a minimal install. That's just fine. And yep, everything else is good. So we're just going to click on begin installation. All right, so while that's going along, I will assign a password to the root account. And let's create a user account for art of server. Make this an administrator. All right, so we just have to wait for the installation to finish. So I will fast forward through this part of the recording and then get back to you when this is done. All right, guys, looks like the installation is complete. I'm going to go ahead and click on reboot. I'm going to go pull that USB drive, the installation media out. All right, guys, so here we are at the Grub boot screen, and I fast forwarded through most of the post process just because I know you guys probably don't really care to see all of that in real time, but I'm going to press enter here and let this run in real time so you kind of get a sense of how fast it can boot up on the NVMe drive. All right, that's it, guys. So let's go ahead and log in. So yeah, that was actually in real time from the moment I press enter in the Grub screen till the login prompt just now. That was fully in real time. So you can see it's booting up extremely fast, and that's because the entire operating system, other than the /boot partition, is on the NVMe drive. And so let me just kind of explain to you how this process works. So basically, the system BIOS on this legacy system doesn't understand NVMe at all, right? It doesn't know that those things exist and doesn't know how to communicate with them. But it does know how to communicate with other more legacy devices, USB drives, hard drives, SSDs, or just kind of standard SATA or SAS devices, right? And so we're kind of taking advantage of the fact that it can recognize the USB drive And so the USB drive contains this content right here that I'm showing you. And basically this is the Grub bootloader that's in here, as well as the Linux kernel. And so the boot sector on this USB drive is what the hardware is booting, right? The server is actually booting the USB drive. The USB drive has a boot sector that points to Grub, and Grub is also resides on this USB drive. And Grub knows how to read this partition, and Grub then looks into this partition and loads a specific kernel, and that's basically configured through the Grub configuration. And that kernel here is the VM Linux here, okay? And inside the Linux kernel is a driver for the NVMe drive. And so once the kernel fires up and loads all the drivers for all the detected devices, then the NVMe drive becomes available. And from that point on, the boot process needs to look for the root file system, any other well, in the root file system, it should find etcfs tab, and then from there it loads all the other file systems that are that need to be loaded. And so in this case, it would be the /home, the swap partition, all that stuff, and that's all in a logical volume within the volume group that is composed by the NVMe drive itself. And so although you are booting off the USB drive initially, and once the kernel is loaded, the rest of the operating system is on the NVMe drive. And so you basically get the full benefit of booting off of NVMe drive, other than that kind of initial step of loading the kernel. And this area is not written to very often. The only time you're going to really update the /boot partition is when there's a kernel update. During normal operating system usage, running applications and all that other stuff, this partition is pretty much untouched. And so it doesn't need to be very big. In fact, in most installations, it's only like 1 gigabyte. We've gave it the whole 32 gigabytes on that USB drive, which is just fine because we have no other purpose for that USB drive other than to hold the /boot. Now, you can also do this in UEFI mode. It's a little bit different, and I want to kind of just explain that process. In UEFI mode, the UEFI bootloader is going to look for a UEFI partition, basically, which is, I believe, formatted in FAT. And from there is a bootloader that then looks for the kernel. So it's very similar, and then loads the kernel, right? So you're going to need 2 partitions on the USB drive in that case. You're going to need the EFI partition, which is what the UEFI bootloader is going to look for initially, and that's where it's going to find the Grub bootloader. The Grub bootloader will then look for the /boot partition, which holds the kernel. And remember, the Grub has the ability to read those other partitions, file systems, and it can find the kernel, then load the kernel, and then the kernel obviously then loads the driver for NVMe. Then it can see the NVMe drives, and then you can have the rest of the operating system running off of the NVMe drives. Okay, so in that case, just make sure that you put the EFI partition and /boot. So you're going to need 2 items in that case on the USB drive, and then put the rest on the NVMe drive. Okay, so you can do that in both legacy BIOS booting mode or UEFI booting mode. It's just a slight difference in how you separate those partitions. But anyway, there you have it, guys. So you can, in fact, use an NVMe drive to run your operating system in a legacy machine that doesn't have the ability to boot off an NVMe drive, simply by adding this one little USB drive to kind of help it along in getting the NVMe drive recognized. And so this is possible because of the particular bootstrap sequence that Linux uses to boot itself. I don't know if this is available in other operating systems. I do think that I'm using CentOS 7 here, but most Linux operating systems have a very similar boot sequence, and so most likely any Linux distribution that you would prefer to use has the ability to do something like this. I don't know if you can do this with Windows, and I don't know if you can do this with any of the BSD derived things like FreeNAS, TrueNAS, that kind of stuff. But I suspect the boot sequence for the BSDs are probably somewhat similar. I'm just not familiar enough to tell you whether or not that exactly can be done or not, but I suspect it can be. I'm less sure about Windows. If you guys ever messaged me privately, you know that I'm a total idiot when it comes to Windows, so I don't really understand the boot process in Windows. But hey, if any of you guys out there who are more familiar with those other operating systems and think that it is possible to do something like this that I just demonstrated with Linux, please leave a comment down below, okay? Go ahead and share that with us. Share it with me. I'd love to learn a little bit about other operating systems as well. But anyway, this is how you can use an NVMe drive as your operating system boot drive, okay? Although it's not, like, technically it's not the actual boot drive. The boot drive is the USB drive, but we're using that as a kind of stepping stone towards running the rest of the operating system on the NVMe drive. So that is definitely possible, as you just saw. All right, guys, I hope you enjoyed this video. I hope you found this useful, and if you liked it, please give me that thumbs up. And also, if you'd like to support my channel, go check out my eBay store. I've got all sorts of server goodies for you. I'll leave a link down in the video description below. All right, guys, have a wonderful time, and let's wish for a much better 2021. All right, bye-bye.